Okay, let's switch gears now and talk about functions. And I know that a lot of this is review, but make sure you're on board with all of this stuff. Definition. A function is a relation between two variables, x and y, or r and t, or who cares what the letters are, but two variables, where one of them is the independent or input variable and one of them is the output or dependent variable, where for each input of the independent variable x, there is only one associated value of the output y. So essentially here what we're saying is each input has only one output. You're never going to plug in a single x value and get more than one y value out. And we'll talk about that in a minute. Let's see, what else? One-to-one function. A one-to-one function is a function, and that's key there. Maybe that's subtle for some of you. The fact that it's a function and it already has this definition built inside it. It's a function where for each value of the output y, there's only one corresponding input value x. So what does this mean? Well, I guess I could say for each input, there is only one output, and for each output, there is only one input. So let's take a look at these ideas in those three different scenarios. Let's take a look at it numerically. So for our first relationship R that we had taken a look at, I have a collection of ordered pairs. And right away I can tell you that this is a function because none of the input values repeat. So I don't have a chance to match up 2 with multiple outputs. However, so while it is a function, each input has only one output, meaning it is a function. There is a little bit of trouble with the outputs. You'll notice that the first ordered pair 2, 3 and the fourth ordered pair 8, 3 share an output. So, but 2, 3 and 8, 3 have a common output. That is to say, the output 3 has multiple inputs. So this is not one-to-one. So this is a function. Function, but not 1-1, one-to-one. For our inverse, R inverse, because R wasn't one-to-one, we're actually going to have another issue here. That is to say, now the inverse is not a function, because what we have here is the input 3 has multiple outputs or y values associated with it. So this is not a function. So if either one of those was going to be one-to-one, I might make up a third one here. Let's see. A is the collection of ordered pairs 1, 2, 3, -5, 0, 6, 7, 4, 8, -1. Here we have no repeating x values, as well as no repeating y values. So no repeat x or y values. So each input has only one. I'm going to have to move this down here. Let me see. Move all this garbage down a little bit. There we go. So, where was I? Each input has only one output, and each output has only one input. To visualize these graphically, I'm going to use a classic kidney bean blob diagram. So here's a kidney bean, kidney beans, and a blob. And let me duplicate that a couple times. If you've never seen these before, don't worry about it too much. They're pretty straightforward. So just to make this simple, I'll have an output or inputs of 1, 2, 3, an output of 1, 2, 3. They don't have to be the same value. Maybe that's too misleading. Negative 1, 0, 5. 1, 2, 3, negative 1, 0, 5. 1, 2, 3, negative 1, 0, 5. And so in this case, if I have matching these up, whatever my function is, maybe f maps 1 to negative 1, it maps 2 to 5, and it also maps 3 to 5. This is a function, but not 1 to 1. Why is that? Because on the left side, each input value corresponds to only one output value, but it's not 1 to 1 because this output has multiple inputs. That is to say, the two arrowheads combine at 5, and you can't have that. That's what makes it not 1 to 1. Whereas if you had 1 maps to negative 1, 2 maps to 0, 2 maps to 5, this would not be a function. Not a function. And the reason there would be you have this output 2 corresponding to two different outputs, 0 and 5, and so we have two arrows leaving the same value, meaning that it's not a function. Whereas if you're going to have something that's 1 to 1, it's a lot like penguins, man. They have to mate for life. You can't have two running around with on 0 with 5. That is to say, each input value corresponds to only one output value and vice versa. So we're talking about a 1-to-1 correspondence or a 1-to-1 mating between the values here. So this is a 1-to-1 function. And that's a good way to visualize what's going on here. So in this case, I don't have more than one arrow associated with any one input or output value. Okay, so that's the idea numerically. Let's take a look at this idea graphically. What we're talking about here is basically the vertical line test, which says that if any vertical line intersects the graph more than once, the graph is not a function. And then, of course, we have the horizontal line test. If any horizontal line, let's make this easy. If any horizontal line intersects the graph more than once, whoops, let's duplicate that. Intersects the graph more than once, the graph is not 1-to-1. So here we go. If I just draw a simple vertical line here, let's see. Let's get a different color. There's a vertical line, and it only seems to hit this graph once at that location. But if I bring it over here, it's going to intersect this graph multiple times. And what's going on here is you have an x value, maybe x equals -2, that corresponds to multiple y values, y1, y2, y3. So what the vertical line test is doing is when you draw a vertical line, each vertical line is an input. Each vertical line is an input. And if it intersects the graph more than once, then it's going to correspond to multiple outputs. Corresponds to multiple outputs. This fails the vertical line test. The next two pass the vertical line test, right? So if I draw a vertical line and I move it back and forth anywhere here, you can see that at any spot it's only going to intersect the graph once. And the same is true here. Okay, so these both pass the vertical line test. So let's see. Passes VLT. Passes VLT. So that means that this is a function, and this is a function. Okay, and then we have the horizontal line test. Let's get a different color here. If I draw a horizontal line, you can see that this one also fails the horizontal line test. And we might say that it's not one-to-one, but that's a little bit redundant because if you guys recall the definition of one-to-one, it first has to be a function. So there's no point in talking about the horizontal line test on this graph since it already doesn't pass the vertical line test. But this, we're now talking about each horizontal line is an output. And this corresponds now to multiple inputs, x1, x2, x3. So this is multiple inputs corresponding to one output. So this is not one-to-one. It fails the horizontal line test. And then finally, when we come over here, if I duplicate this horizontal line, we can see that every horizontal line I could possibly draw is going to pass or intersect this graph only once. So this is going to also be one-to-one because it also passes the horizontal line test. Okay, so those are just some basics graphically. Now let's talk about these things algebraically or analytically. This is probably a little bit weird at first because you might not know what you're looking for. But it's maybe a little bit hard to tell for some students whether or not something's a function just by looking at it, or whether or not it's a one-to-one function just by looking at it. Well, the idea is, if we solve this for y, and this is already solved for y, there is no plus or minus values or any kind of bit of this function that's going to spit out multiple answers. That is to say, each single x value will only generate a single y value here. And if we solve this for x, if we add 2 and then divide by 3, oops, on. Divide by 3, then we can see that the same thing is going to happen for x. No, or each single y value will only generate a single x value. So this is not only a function because of this idea, but it's also one-to-one because it has both of these features. Now, for the next one, y equals x squared, this same statement is true. Make that a little bit smaller. The same statement is true. But x equals plus or minus the square root of y. Now we can see, oh, bunk. Many y values will generate multiple x values. For example, if y equals 1, then x is equal to plus or minus the square root of 1, which is plus or minus 1, which means we have 1, 1, and 1, negative 1 as ordered pairs. And this is, sorry, I have that backwards. This is 1, 1, and negative 1, 1. And we can see that they share a y value, but have different x values. And that it makes us unhappy. Not 1 to 1. So this is not 1 to 1. Okay. For the next one, in both cases, if we solve this for x, we get x is equal to plus or minus the square root of 1 minus y squared. And we can see right away it's going to generate multiple x values for any y, as well as y is equal to plus or minus the square root of 1 minus x squared. And so again, this is not a function, and thus it can't be 1 to 1. In this particular case, if we solve this for y, y is equal to plus or minus x. And so this is going to fail the vertical line test, or is not a function. So what we're really looking to key in on here is this plus or minus relationship. So anyway, keep those ideas in mind analytically. It's not going to be too much of a big deal. But the question is now, how do inverses, functions, and one-to-one functions relate to one another?